An apple serves to penetrate his pate. Natural laws can guide man's fate. And thus we learn that motion involves more than just commotion. Motion involves reaction, force, and speed. A whole new physical creed. Laws that men and missiles must heed. Sir Isaac Newton found that things stay where they are unless something makes them move. Speed and direction depend upon an object's weight, the force exerted, and angle at which applied. Oh yes, he also found that to every action there is an equal and opposite reaction. Action, reaction. It's not fire and hot gases shooting out the open end that makes a rocket move. It's high-pressure gases pushing against the closed end of the rocket. Action, reaction. High-pressure gases are a product of burning within a rocket motor. Two things are required to support the burning: fuel and oxidizer. Both are carried in separate tanks in a liquid fuel rocket, then mixed and burned in a combustion chamber. Or they can be mixed together into an easily handled solid composition. This is a solid fuel rocket motor. Its combustion chamber is a hole down the center. Whatever the type, the rocket motor provides the push that makes a missile go. This was once a standard Army missile. If there were no resistance, the arrow would travel forever in a straight line at constant speed. Air slows the arrow, however, and winds tend to blow it off course, and its weight tends to pull it down. Thus, a bowman learned that accuracy depended upon the angle, force, and direction in which he fired his shot. The same things influence soldiers of today and the accuracy of their weapon, an Honest John rocket. Honest John uses a rocket motor instead of a bowstring, and its nose is packed with explosive, but it must obey the same physical laws as the arrow. A simple, rugged weapon is needed if bull's-eye accuracy is required. Something called a guidance system. There are many types. For example, a whirling gyroscope and devices that measure speed and direction combine to form an inertial guide system. With it, a missile carries a built-in road map, a way to stay on course in spite of wind and other outside influences. That's the secret of the U.S. Army's Sunday Punch, the Pershing ballistic missile. It can hit a target 400 miles away. The soldiers compute an ideal flight path from the firing point to the target and give it to the missile. Once in the air, no human hand steers Pershing. Its inertial guidance system keeps it on course to its target. Unlike rockets and ballistic missiles, guided missiles can and do change direction in flight. The Army's Nike Hercules is an air defense guided missile. It uses something called command guidance. It takes its orders from the ground, where soldiers and electronic computers make the decisions. Radar sends signals that steer Hercules to its target. That combination is bad news for airplanes. There are other ways to do the job. High-powered radar can be used like a searchlight. and the missile can be sent aloft to home or steer itself using radar signals bounced off the target. That's how the Army's Hawk air defense guided missile works. Hawk was specially designed to handle low-flying, high-speed airplanes. The Army's shoulder-fired Red Eye also is a homing air defense missile. But this front-line weapon has a seeker in its nose that steers the missile unerringly to the heat of the engine of the target aircraft. The Army even sends missiles by wire. Its new TOW missile, now in development, gets its steering commands through hair-thin wires trailing behind it. The gunner sights on the target, and a tiny computer automatically directs the missile to his aiming point. Land combat is the soldier's job. It's rugged and complicated, and no one weapon can do everything. That's why the Army needs many missiles. They give the American soldier better firepower, a means to fight and defeat any enemy. What really counts is an effective combination of both man and missile. To hit targets on the ground far beyond the reach of guns, the Army needs long-range ballistic missiles, like the Sergeant. Up front, at close range, the soldier needs a quick punch like the M72 rocket grenade, light enough to carry on his back, and big enough to do the job. Lightweight weapons are important too, especially on helicopters, where only a limited number of pounds can be lifted. A simple, well-aimed rocket is extremely effective, as Army aviators proved in Vietnam. Against a heavily armed and armored target, the rule is to destroy him before he destroys you. The requirement, hit at long range and hit hard on the very first try. The Army's Shillelagh guided missile has the accuracy and the punch to fill the need. And when developing an effective way to destroy attacking missiles, intercontinental ballistic missiles traveling at the rate of 3 miles each second, the Army needs speed. Speed like this in the Zeus missile, planned to race great distances and intercept and kill attacking missiles. Or speed like this in the even faster Sprint, designed for short-range missile intercepts. The Army has special requirements for its soldiers and its missiles. Army missiles must go with the soldier and fight where he fights. That could be in any climate, any place in the world. There are places where it gets well below zero every day, or where the temperature gets well above 100 degrees in the daytime, and places in the world where it rains constantly and mold forms overnight on metal parts. A mobile, modern Army needs missiles that can move. Depending upon the mission, they travel on tracks, or on backs, over land, or over water. And when natural obstacles intervene, Army missiles come by helicopter, under them, in them, or on them. Army missiles can ride transport aircraft for a quick, long jump to battle zones anywhere in the world, and get into the fight, if they must, with one last step, straight down. And once in the fight, Army missiles can throw a variety of punches. This Lance ballistic missile, for example, delivers a nuclear, non-nuclear, or special-purpose warhead, depending upon the soldier's needs. A variety of missiles to do a variety of tough Army jobs. They are built by American industry, but they have a common home address: Redstone Arsenal, Alabama. Here, men and women of the United States Army Missile Command, a major commodity command of the Army Materiel Command, manage the worldwide effort by a government industry team required to develop and build missiles to meet the soldier's needs, get them to him, and make sure they stay ready to go if needed. And here at Redstone, at industrial plants, at test ranges and other government installations all across the United States, a continuing search has but one objective: a good weapon in the soldier's hands today, a better one on the way. It's a long jump from today into the future, and it requires contributions from all the sciences. More efficient rocket fuels, low-cost, high-accuracy guidance systems, better metal alloys for missile structures, and a hard look at the shape of things to come. The essential ingredients are skill, ingenuity, and dedication. The Army calls it the missile business. A business with a single customer: the American soldier. Without him, the world's best missiles are brainless pieces of metal. With him, they share a vital part in the defense of freedom.